Hi, I'm Rob Steppen, Applications Development Specialist here at Univar Solutions. At Univar, we're all about innovation. We keep our customers and suppliers front of mind. This is especially important in the multifaceted world known as the metalworking fluids industry. The metalworking fluids world has as many formulations as can be imagined, accomplishing the work needed. Sustainability has become an important and growing aspect of this world. It is vital that we stay at the forefront of development and harness each innovation whenever possible to deliver on performance, on cost, and especially on sustainability. The work we do brings value to our customers and to our suppliers. At our Houston Solutions Center, we are well equipped to tackle a variety of challenges and development projects supporting the metalworking fluids market. From formulating a next-generation water-based, fully synthetic metalworking fluid, to finding ways to improving the performance of new, sustainable products. We have the people and we have the equipment to make this happen. Whether you're a customer or a raw material supplier, we can assist you with developing new formulas, modifying existing formulas, and carrying out performance testing and analysis. In today's demonstration, we'd like to focus on the performance of the formulations we've developed. This is especially important today given the tremendous demand on this growing, broad market. This is phase one in our planned multi-year sustainable product development for this market. Today, the focus on sustainable systems presents an opportunity to improve and enhance performance. Figuring out the necessary components to put together a product that meets sustainability criteria and yet delivers the needed performance in each machining requirement. The technologies used for sustainable metalworking fluids are old and new, as evidenced by the base oil selection in this phase of our product development. But it is growing with new additives and novel base oils. Today, we like to focus on three base oil types, which have been in the market for a while: canola oil, sunflower oil, and soybean oil. We will discuss the different base oils and why we choose them in the first phase of the product development. These products are familiar to most metalworking fluid manufacturers, as they've been used for decades for the excellent lubricity for certain types of machining operations. Today, we're also developing innovative products addressing sustainability by taking a hard look at what is available that can be used for customer sustainability efforts. These products were a natural place to start. Additionally, these products are readily available and are known entities to most formulators. The central issues with them is their lack of oxidative and bioresistant stability. Those were kept at the top of our minds in formulating working products and addressed with the best available technology today. When formulating a cutting fluid, it's important to know the application. For example, ferrous versus non-ferrous machining. A big challenge is to provide formulations that meets the needs of both those metals. And how do we do that? One way is to be able to have a multifunctional component that provides corrosion inhibition, anti-wear, and also extreme pressure for both ferrous and non-ferrous formulations. The working pH of any given metalworking fluid is a key indicator of the fluid's health. Whether a coolant, washing compound, or water-based corrosion preventative, while the optimal pH for any given fluid or situation differs, there is a pH for your fluid mixed at your concentration and used in your machine where the pH of the fluid will stabilize. Most metal removal fluids are alkaline, meaning they have a pH above 7. For a variety of necessary compromises, a metalworking fluid typically has a pH between 8.5 and 10.5. Most coolants today are formulated to include rust preventatives. These rust inhibitors provide a protective barrier on the metal surface. The cast iron chip test, known as the ASTM D4627, is a good indicator of a water-soluble product's rust preventative qualities. Measuring bacteria levels should be completed along with the checks on fluid quality, for example, pH levels and fluid concentration. Bacterial contamination will affect the quality of metalworking fluid. In addition to decreasing quality, this contamination can also lead to substantial health risks for employees and users that encounter the fluid. The most common way to measure microbial activity is the use of dip slides. The HSE recommends using dip slides to monitor the general activity of aerobic bacteria. A dip slide is a sterile culture medium used to dip into the liquid to test the levels of bacteria. The dip slides are then incubated, typically for 4 to 8 hours at 30 degrees Celsius to allow for any microbial growth. A reference chart is then used to compare the results and trend activity over time. Each dip slide is dual-sided, and each type of agar tests for a different group of microorganisms. Foam is typically considered to be an undesirable property in metalworking fluids. High foam levels in metalworking can be challenging as they can flood equipment and make it difficult to see the tool and the workpiece, which can inhibit manufacturing efficiency. Since most metalworking fluids have good cleansing properties to help keep machines clean, they may foam when agitated. The quantity of foam that occurs depends upon the chemical composition of the metalworking fluid product, the quality of the water used for mixing, and the degree of agitation in the system are the main parameters to be aware of. Micro-tapping torque is an important test in the world of metalworking fluids and used to screen formulations to ensure basic performance needs are being met. ASTM D8288 is the methodology used for the screening test. The test has relevance for other metal cutting applications beyond tapping, such as sawing, milling, or honing. The Artec Tribometer MFT 5000 is the world's most advanced tribometer. The instrument is designed to evaluate friction, wear, mechanical properties of materials, as well as lubricants over time. The MFT 5000 is used extensively in industries such as metalworking fluids, lubricants, oil, and grease. With its robust modular platform with a wide range of interchangeable modules and sensors, which allows the instrument to combine several tribological tools in an all-in-one device. Cutting tool tribology allows the user to simulate and improve the cutting tool process in a lab-scale setup. Same real process parameters and finished component mounting generates useful data at a rapid pace. Stay with us to see this state-of-the-art piece of equipment in action, and we thank you for joining us. Contact us if you're ready to get started on your next lubricant and metalworking solution.
Thank you for joining the presentation today. I am Jesse Zierbo, Senior Innovation Chemist at our Houston Solutions Center. With me today are John Hart, Application Development Specialist, and Rob Steffen, who is also an Application Development Specialist. There's great discussion around the path towards greener technology and sustainability in the lubricants, grease, and metalworking fluids industry. We would like to dive deep more into some specific questions in regards to the video you just watched. Question 1, what performance characteristics do sustainable dibasic acid complexes such as amine and monohydric alcohols offer to the metalworking process? Rob, would you like to take this question?
Yeah, I think good question, Jesse. I think that the diesters are commonly used in things like compressor oils and engine formulations. But in metalworking, they have the advantage of being able to be put into a water system as an emulsion or even a true solution, providing extreme pressure, anti-wear, and especially boundary lubrication. So running the film formation, they're clean, they're bio-derived, they're low toxicity, and their ability to prevent metal-to-metal contact is really where these things shine.
You get that bio-derived products now that are being developed that have very high performance. Right along with what Rob was saying, we can see some data from these types of products that provide the performance characteristics that you need related to coefficient of friction and load carrying capacity, all of that, but also not providing any toxicity issues that makes it easier for the end users and also for the waste removal as well. It's not as problematic as what some of the older chemistries were. So that stuff is what we're seeing is some really good progress from the chemistries being utilized.
Exactly.
As the data comes out with the bio-derived products, do you see more of a shift where people are converting from a petroleum base into the bio-derived base stock products for their metalworking fluids?
Yeah,
Yes.
I think I'll go ahead first. I've seen that starting to happen in different parts of the country, where people are taking a great deal of notice towards utilizing products that have much better profiles from a labeling perspective and from an environmental perspective. There's customers out there that are on the bleeding edge of doing everything biorenewable, sustainable, all of that, and we're definitely helping to support that type of drive. And I think you're going to see a lot more customers looking to utilize these types of products because their performance levels have been increased, even though they may not have some of the let's say uglier chemistries of the past. Rob, what do you think?
Absolutely, John. And I think that, and what we showed earlier in our video, Jesse and I, is that we're proving out and displaying that sustainable formulations and alternative sustainable formulations have just as much strength as far as extreme pressure, anti-wear, and they also have the advantage of having better boundary lubrication in every case, especially against just 100 oil or something that's typically used in a soluble oil. I think also, you look at some of the materials that are going in these sustainable systems. I mean, they're basically either borderline food grade or cosmetic grade type materials. So the skin irritation that goes on with all the stronger chemistries that are in prior use are going away, and it's giving the workers a safer place to work, and also disposal because of the biodegradability. I mean, it just goes from soup to nuts on all that, for cradle to grave, and I think that's where the drive is coming from.
Question 2, what are the market performance characteristics of sustainable base fluids? I'll take this one. Lubricants offer several attraction advantages when compared to traditional petroleum lubricant base stocks, such as high viscosity index, higher flash point, lower volatility, lower evaporation loss. They provide an excellent source for incidental food contact in processing plants, such as food, pharmaceutical. They have a very low environmental impact, superior solubility with additive chemistry, and enhanced lubricity due to their polar nature, which can lead to improved performance, efficiency, and extended tool life for the end user.
Yeah, I think that as we showed in being formulating chemists, I think that early on it was a challenge to get some of these bio-derived and sustainable materials into a stable emulsion. But I think that is just complete. That landscape has changed completely. There's so many choices now that are strong and based, and as we displayed earlier with the nice clear, stable metalworking fluid that we made. I think so. It's showing that it's possible. It's not difficult, and that the results can be advantageous over the other choices that are more environmentally unfavorable.
Also, I think durability plays a big factor too. Longevity in the sump. I think some of these newer products are helping to expand the life of what historically have been products that couldn't last that long. Now We're starting to see things that could last just as long as the petroleum products and provide same as or better than performance than what people have seen historically, which also helps support the credibility of these products and make them much more acceptable into the marketplace.
Agreed. Yep.
Question 3, What are the performance characteristics of high oleic and thermal modified triglyceride oils? John, would you like to take this one?
Sure. I think what you're finding is just like we spoke about on the last question was the durability aspect of these products. They're starting to be able to last longer. They have a much higher load capacity, lower coefficient of friction. So you're reducing the temperature at the point of contact between the tool and the workpiece. And you can carry that heat away that is generated. It doesn't require as much torque to be able to put that tool through the workpiece. It's a whole lot of better performance characteristics than what you could get from the older style oil-based products. And I think that is making a very big push. And also what Rob said earlier about emulsion stability, that's been a problem in the past as well. I think those things are starting to be overcome with some of the newer chemistries that are out there. Even some of the older chemistries can do a good job with that. What do you think, Rob?
Absolutely. Yeah, I think that also that we're looking at, so if we look at some of the triglyceride oils, let's say sunflower, canola, and the ones that we looked at, Jess, I think that, when you look at the high oleic version of these, and these were all driven by the food industry. And so now they cross over into metalworking, and people who are formulating are looking at, oh, okay, these are really for higher temperature stability, lower toxicity, those kind of less rancidity, et cetera. Yeah. And now that's landed into metalworking fluids, and I think there's a lot more available to formulate with that are sustainable, as John said, with the surfactants, the anti-wear, the extreme pressure, the boundary lubrication, the corrosion inhibitors, which we showed earlier in our formulations. And I think that they're viable and they're sustainable. And also what John brought up is an important fact that they're durable. And that's something that has in the past has been like kind of a stop point for a lot of people using them.
Yep. The availability of the products makes it more attractable too. When there's a potential shortage in petroleum, this gives the end user some variability in formulation also too.
Good point.
Question 4, do you guys see a shift from soluble oils into synthetic metalworking fluids?
Absolutely. I think, like I said, historically, I think, metalworking was done exclusively with oil, and this goes in the past. And then there was a drive towards more cooling, because the cooling part of, and that's why they're called coolants, because an important factor in tool life and good machinability is the fact that you remove heat. And you have to have some friction to remove metal. I mean, it's just a fact. So you're creating heat. So when they started to take these oils and they said, well, let's put them into water. We're going to add surfactants and some coupling agents, etc. And they're going to go into and now we have a metalworking fluid that's called a soluble oil. But they're pretty problematic because the oil itself is very nonpolar. So the emulsions tend to be very loose, unstable. They take on a lot of tramp oil because it's similar to the composition of the actual metalworking fluid. And you end up with a lot of housekeeping and dumping systems and cleaning, etc. So the next step was semi-synthetic, which is kind of a hybrid between a soluble oil and a synthetic, kind of in the midway. So that gives you some of the lubricating properties of the oil, but it also adds the synthetic durability. And then finally, at the top of the tower is going to be synthetic. So those have fantastic cooling properties. They're very durable. They're usually bios-derived or very low toxicity. They're super efficient. And I think that's where, eventually everything's going to end up into this landing on semi-synthetic for sure, and definitely moving into the synthetics as we see this progression.
Yeah, I've seen a lot more discussions around the semis and the full synthetics here over the last couple of years. People are looking at different types of substrates. They're much more difficult metals to machine. You're seeing higher temperatures as a result. So you kind of have to start moving up that pyramid from soluble to semi-synthetics, and in some cases full synthetics, to be able to do the job that's needed to do to take that heat away from machining those metals. And I think you're also starting to see a newer trend towards biostability, where you're able to formulate these products without biocides as a part of it. I think that's something that's developing and is going to continue to develop over the next couple of years, where you're going to see some interesting formulations coming out of that. And I believe you're going to see a growth in the semi-synthetics and the full synthetics for sure.
Yeah, good point, John. I think another thing that's a salient point to that is because of the high pressure systems that are being incorporated, 4,000 to 6,000 PSI, especially with non-ferrous, aluminum can be a bit sticky, and you want to remove those chips and the fragments out. And this allows the machining program to have higher speeds and faster movement from one part to the next. And I think that one of the inherent properties of some of these synthetic components is their low foam properties.
Bingo.
So when you look at, if we looked at what we were talking about before, where you have a soluble oil, so those are loaded with soaps and surfactants, and they foam, and that foam lowers the density of the fluid. Just picture a beaker with foam in it versus a beaker with pure metalworking fluid. You can see that you're missing a lot of that lubrication and cooling that can happen with the system without foam. And I think, and foam can also collapse and cause, biomass, can cause, it's harder to remove heat out of the sump because it acts as an insulator. So these synthetic systems are typically, like we showed in our experiment, the low foam, inherent low foam properties of these systems are preferred especially in the high pressure systems.
That concludes the end of our Q&A session. Once again, thank you for joining our presentation today. If you would like to hear more about what you saw in today's presentation or have additional questions, our contact information will be dropped in the chat below. We look forward to working with you on your next solution.